So we continue with this problem with the monastery on the hill and the cable car, and now we're going to have a look at the elevator shaft. And so we need to introduce the concept of a normal to a tangent as well. So here we have the hill, we have found the equation for the tangent, and now we want to consider the normal, which is perpendicular to that line. So we can type in a definition here. A normal to a line is perpendicular to that line. If a line has gradient m, the normal has the gradient. I'm going to draw that instead. That's a bit easier. So if a line has a gradient m, the normal has the gradient minus 1 divided by m. And we'll keep writing. If two lines are perpendicular to each other, the product of the two gradients is -1. Right, so we can frame this definition. So that's a normal to a line. Now we can always check to see, I mean, if we have the gradient of one line and then we multiply that with the gradient of the normal, then that should be right, that's going to be minus m divided by m, and that's -1. All right, so that's correct. So our second objective then, would be to find the entry point for the support structure. So we want to find the coordinate for this point here. And we begin with the equation for the normal to our tangent y. So our tangent, that was f of x equals 1.4x plus 50. And in this case, it's easier if we write 1.4 as a fraction. So Jacob is going to love this. 1.4 is the same as 1.4 divided by 1, right? So write that 1.4 equals 1.4 divided by 1. And there's nothing stopping me from multiplying this with 10. So that'll give me 14 divided by 10, which is the same as 7 divided by 5 if I just divide both of them with 2. So we have indeed a new equation here. We have 7/5 x plus 50. So that's the same number. 7/5 is the same as 1.4. And there's a good reason why we want to write this as a fraction. Now, since the gradients of line and its normal have the relation m, let's see, so this is the gradient of 1, and the other one has the gradient of minus 1 divided by m. the gradient of the normal must be, and I mean, we could have a look at what we do with the gradient. Okay, so we take the gradient of the line, the tangent, and to find the gradient of the normal, we have to, what do we have to do? We have to change the sign. So it's, if it's positive, it must be negative. And we also flip the fraction upside down because m is the same as m divided by 1. So we're flipping the fraction upside down and we change the sign. So flip it upside down, change the sign. So gradient of normal must be 5 divided by 7 with a minus in front of it, right? Now, the two lines go through the same point. Um, so normal also goes through the point that we found before, 50, 120. We can see that from the sketch. So that's that point up here. Yeah. So this is the point 50, 120, and we're interested in this point here. But now we have a gradient. It's minus 5 divided by 7. And we also know that this normal goes through this point here. So we can find the equation for the normal by using the point gradient formula again. So this was y equals m x minus x1. So we're using the other form now, which is easier to use. So that's the point gradient formula. So y equals, and now we have to use the new gradient, minus 5 divided by 7 x, and now we have minus minus, so that's going to be plus 5 divided by 7 multiplied with 50 plus 120. So now we're using the point 50, 120, and we're using the new gradient for the normal, minus 5 divided by 7. And that gives us, right, let's see, y equals minus 5, 7, 5 divided by 7x plus 250 divided by 7 plus 120. And finally here we can write these as decimal numbers. That makes more sense when we want to draw it. So we have minus 0.714x plus 155.71. So that's the equation for the normal to the tangent. And the entry point will be the intersection point between the graphs of the tangent and the normal. Sorry, my mistake. The intersection point, right? So here we have f here, right? And then we have the normal here. Let's call that n. So the intersection point between the normal and the original function, that would be the entry point for this elevator shaft. So we need to set up this equation minus 0.02x squared plus 3.4x is equal to minus 0.714x plus 155.71. And solving this equation will give us the x value of the intersection point. And you're better off with a graph solution on this one. So find the two solutions. There's going to be two solutions, one here and one here. And this is the one we're interested in now. And that's going to be x coordinate 155.7. And the y coordinate is going to be 44.5. So the answer is, yeah, that's the answer. So the coordinates for the point. So the entry point is this point here with these coordinates.